Good afternoon, everybody. Just going to give it a minute just to let everybody in, and then we'll get started. Okay. Thank you for joining us this afternoon. So today's webinar is called Harnessing AI and Remote Sensing for Smarter Biodiversity Assessments. And we're joined today by experts from AiDASH, AtkinsRéalis, and the Wildfowl Wetlands Trust. If you have any questions today throughout the webinar, please pop them in the Q&A. You can find that at the bottom of your screen, so just click on it and type in your question, and we'll get to those hopefully at the end of today's presentation. So we've got several speakers today. I'm going to pass you over in a moment, and they're going to be telling us all about their providing a practical guide to using AI for large-scale projects through real-world case studies. And this is a joint project that's been run between AiDASH, AtkinsRéalis and WWT. So Lizzie, can I pass over to you, please?
Brilliant. Thanks, Sarah. So yeah, like Sarah said, we're going to be talking about harnessing the power of AI and remote sensing to help enhance biodiversity assessments using the Eelscapes project as a case study. My name's Lizzie Hall, and I'm an Associate Director at AtkinsRéalis. I've got a particular focus on large-scale biodiversity net gain at the moment, and I coordinated the Eelscapes project. So I'll just pass over to the other presenters today for them to introduce themselves. So Lauren, did you want to go first?
Sure, I'll get us started. My name is Lauren Weller, and I'm a Senior Ecologist and Compliance Lead at AiDASH, where I work on solutions regarding natural capital and B&G. My experience includes over 15 years in the industry across Africa, North America, and the Middle East, and now the UK as well.
Thanks, Lauren. Elle, did you want to introduce yourself?
Hi there, everyone. I'm Eleanor Miles, and I'm a senior geomorphologist at AtkinsRéalis. I'm an accredited Morph Pro surveyor, and I lead our watercourse biodiversity net gain team of aquatic scientists. I also work closely with landscape recovery projects to help develop digital solutions to working at the landscape scale.
Thanks, Elle. Ashley, did you want to introduce yourself as well?
Hi, I'm Ashley White. I'm Senior Project Manager for the development phase of Eelscapes. It's a partnership between WWT, Gloucestershire Wildlife Trust and the Environment Agency, working with 22 land managers, and it's a round one landscape recovery pilot.
Thanks, Ashley. Do you want to just click on to the next slide, Anastasia? It's just got our agenda. So this is what we're going to be covering today. I will start by giving an overview of the Eelscapes project. So if you just flick onto the next slide. Thanks, Anastasia. So Eelscapes is a landscape scale project that aims to restore nature-rich wetlands along the River Severn from Tewkesbury to Gloucester. You can see the location on the image here. And these habitats will help the endangered European eel and the rare true fox sedge. These are the flagship species of the project, if you like. But lots of other wildlife will also benefit from this project, as well as improvements to climate resilience. WWT, the Gloucestershire Wildlife Trust, and the Environment Agency are working with people in the area who own, manage, and use the land. Thanks, Anastasia. So Eelscapes is a landscape recovery project. It's funded by Natural England under a DEFRA landscape recovery project development grant. And this is part of the new environmental land management schemes, which have replaced former EU agricultural funding. Landscape recovery projects are large-scale, long-term initiatives that aim to restore and enhance degraded or damaged natural landscapes. They involve habitat restoration, land use change, and collaboration among multiple partners to achieve environmental and community benefits. So once a project has applied for landscape recovery and has been accepted, it proceeds to the project development phase. One of the key tasks during the project development phase is collecting baseline data, including baseline habitat data. And that's really important for understanding the current state of an ecosystem before any interventions. And it also provides a reference point for measuring progress and evaluating effectiveness of recovery efforts. And DEFRA stipulate that the baseline habitat is established using the statutory biodiversity metric. So Eelscapes is a round 1 landscape recovery project that has just submitted full project plans for negotiation to DEFRA. And if it's successful, it will move from the development phase into the implementation phase. So we came into this project to help with collecting the baseline habitat data, including the condition assessment data. That was our role on the project, and that's going to be the focus of this webinar. But there are challenges in meeting landscape recovery requirements with traditional surveys. When a project area is large, as in this case, the Eelscapes project covers 1,700 hectares, and physically surveying that area is time-consuming and costly. Seasonal survey restrictions, multiple landowners, and difficult to access areas add another layer of complexity. Plus, habitat surveys become out of date and need repeating. And when a project is at the optioneering stage, this could lead to a significant amount of abortive work. So AtkinsRéalis and AiDASH developed a collaborative solution to support the project, involving a combination of AI and remote sensing using AiDASH's BNG AI platform and AtkinsRéalis's River Studio tool, combined with targeted ground truthing. Critically, we agreed the approach with DEFRA in advance. I'm just going to show a sort of high-level overview of the solution before we go into a bit more detail. So the first step was to review any existing data about the area. Then we undertook an initial habitat classification and condition assessment using those digital tools, the BNG AI tool and the River Studio tool. And Lauren and Elle are going to go into a bit more detail about those shortly. Then we undertook ground surveys in line with a ground survey strategy that we developed with the project team. The primary focus of the ground surveys was to ground truth the models, and priority was given to higher distinctiveness habitats and areas where no prior survey data existed, so areas of highest uncertainty. And we also took into consideration locations where future interventions are most likely. And then we were able to refine the models using the ground survey data to increase accuracy across the entire project area. And the BNG AI platform hosted by AiDASH was available to the whole project team, and that provided a powerful focal point for the project and for data interrogation. So I'm going to hand over to Elle now, who is going to talk in a bit more detail about the River Studio tool.
Brilliant, thanks Lizzie. So given the nature of the Eelscapes project and its focus on eels and sedges, there are an awful lot of rivers within that project area that require an assessment of baseline river condition. And this is a bit of a challenge because river condition is assessed very differently to the other habitats within the biodiversity metric and within the landscape recovery guidance. And the biodiversity metric and the landscape recovery guidance both suggest using the river condition assessment methodology to assess river condition. And this was developed by Queen Mary University and cartographer. And it is a very in-depth methodology that relies on morph field surveys to capture the different characteristics of the channel, of the water margins, of the river banks, and of the bank top habitats within that riparian zone. As well as the field surveys, there is also a desk-based component to determine the type of river within which a survey reach sits in. These two components together tell us whether a river reach is good, fairly good, moderate, fairly poor, or poor condition. So an awful lot of work goes into determining river condition. And while this method is fabulous at giving us a really high level of detail about how our river is functioning, it is not feasible to conduct this many detailed surveys across kilometres and kilometres of river at this stage of the landscape recovery project, as Lizzie has just gone into. So therefore, we suggested using AtkinsRéalis's in-house River Studio model to estimate the river condition for each reach within that large project area. And River Studio is a bespoke tool, and it uses open source satellite-derived data from the Environment Agency, like LiDAR, from Natural England and from Ordnance Survey. And it combines these satellite-derived data sets with regulatory and citizen science surveys, and with asset data from where there are barriers that have been recorded, or structures within the river channel, or CSOs. And it's this extra level of detail that is really helpful in determining river condition. So following the flowchart on the right-hand side, the model uses all this information to split the river into distinct river reaches. It then uses relationships that have been developed from peer-reviewed papers and expert judgment to assess the river type indicators and also the remaining condition indicators, which tell us how natural or how modified a river is. It then brings all that information together and combines it together to estimate our condition class. So good, moderate, poor. Now for eelscapes, we used a targeted approach to bringing in morph surveys and going out on site to ground truth and refine that model, those model assumptions. And this was beneficial for two reasons. One, because then we could refine those model assumptions using really site-specific information that was appropriate to the Eelscapes project area, but it also allowed us to provide a level of confidence in the model outputs for the Eelscapes project team. Thanks, Anastasia. So I will now go through some of our results. So for that first step of the assessment, our river type assessment, the River Studio modelled two types of river based on the substrate size of the river, how meandering the river was, the gradient of the river, and the river width. And the two types the model found were a straight sinuous silty clay river type, or type K, using the river condition assessment terminology. And we were finding these in the tributaries of the River Severn, within the floodplain, and those smaller streams. We also had some rivers within the project area that were of a large river type. So they were over 30 meters wide, and this was primarily the River Severn itself. So when we went away and did our manual assessment of the river condition assessment to understand river type, we compared that against the modelled outputs, and we found that the River Studio river type assessment was 100% accurate when compared to the manual assessment, which we were very happy with. But here it gets a little bit more complicated. So I mentioned that there were 40 indicators of river condition. Now only 8 of those represent river type. And the full list of the indicators is in the table on the right-hand side of your screen here. But we felt that the open source data was only appropriate. We were only comfortable using it to assess 28 of those indicators, and they're the ones shown in green. And the reason for this is because some of the data sets that we had just didn't provide the level of detail about for example, bed siltation, the extent of bed siltation, the different types of physical features that were present, if there were bars or berms in the channel, different types of macrophytes. We just didn't have that level of detail. In some other instances, open source datasets were available, for example, about invasive species, but they didn't provide us with the spatial resolution that we required to accurately separate one reach from the other in terms of invasive species. So we have, sorry, can we go back a sec? Thank you. So we have all of these different indicators, and some of them are positive indicators, which are shown in bold on the right-hand side, and they range from 0 to +4. And these are showing all of the kind of natural features of the river that were recorded. And then we have negative indicators, which are shown in italics, which show all the negative more modifications that have happened to the channel. And these range from -4 to 0. And when we compared the morph surveys that we did on site ourselves to the River Studio indicator scores, we found that the vast majority only varied from the survey data by less than 1 point. So that's pretty accurate. We were quite happy with that. But there were a couple of exceptions. And these were for the artificial bank profiles, which we tended to underestimate, and the severity of artificial features, which we tended to overestimate. So this really highlights the importance of field surveys to help refine these model assumptions and make them really site-specific. This allowed us to go back and tweak some of those assumptions and make it work for the Eelscapes area. Thanks, Anastasia. So now what does all of this mean for our final condition score? How accurate were our predictions of good, fairly good, etc.? So the River Studio condition assessment, we found to be 73% accurate when compared to the manual river condition assessment. And those river reaches that were inaccurately classified were only one class away. And this highlights that even with that level of refinement that we managed to do within the model, our model will only be as good as the data that we put into it. So for example, in some more surveys, when we were out on site, we recorded sluices that were present that were not marked on our open source maps. So our model couldn't include them in its predictions. And therefore our model over-predicted how good that river was. But given the speed at which the model can assess river condition over 1,700 hectares of a project area at this scale, to this level of accuracy, it demonstrates the utility of utilizing these existing data sets when working at the landscape scale, especially when we're in the developmental stages of the project. And finally, I just wanted to reflect on the snippet that we have on the right-hand side over there, which shows a little bit what the model outputs look like. We've only got a very small zoomed-in area, and the background is blurred for anonymity. But the outputs of the model are all GIS-compatible shapefiles. It is a line file with each individual river reach, and each individual river reach, all the information sits behind it in terms of the 40 different indicators, which ones we have assessed, which ones we have not assessed, the condition score, and really importantly, the data sources that will have gone into the condition score. And this is to provide a level of transparency and an auditable result.
Can we have the next slide there, Anastasia? So, as Lizzie indicated, surveying for landscape recovery projects which span vast dynamic landscapes can be challenging using traditional methods. Fully manual field surveys can be hard to scale as they're often limited by seasonality, budget, and surveyor availability. And they aren't always designed for repeatable monitoring or rapid optioneering across land areas. This is precisely why at BNGAI we believe in leveraging ecological expertise through technology. So by fusing remote sensing and AI with deep ecological knowledge, we create solutions that go far beyond what either technology or traditional ecology could achieve alone. Remote sensing gives us the eyes to see changes at scale. AI provides the analytical power to process the vast data and identify patterns. But without ecological expertise, we're flying blind. Only ecologists understand what those patterns actually mean for biodiversity and ecosystem health. So when we combine all three, we can monitor ecosystems in real time, predict changes before they become critical, and make decisions that truly protect our natural world. So how does BNGAI actually work in practice? Well, it's built around three core capabilities that seamlessly work together. We start with a preliminary habitat mapping from remote sensing. Then we use technology-driven field validation to ensure accuracy. And finally, we automate the reporting process. This transforms what used to take months into weeks with greater precision and consistency. So let me walk you through the detailed process. Step one is always to define the AOI and match imagery. We start with site boundary information to match the area of interest with commercial-grade satellite imagery. These images are captured during the growing season from April to September or using the most recent quality images available for the baseline year. We then have step two, which is our automated classification. Our image recognition AI models analyze the satellite images to delineate land cover changes and identify habitats. This creates an initial boundary with labeled habitats. We then integrate this with reference data layers like OS and priority habitat inventories to verify and enhance our classifications. All features are mapped according to DEFRA BNG metric guidance, with area habitats as polygons, linear features like hedgerows and watercourses, and individual trees as points. Step three is our expert validation. Our in-house AiDASH ecologists validate the habitat maps to ensure consistent quality. Step four is multiplier application. We apply an average condition data collated from across the country. The model assigns high or low strategic significance. High is generally applied to designated sites or priority habitats, and we automatically assign no encroachment scores to watercourses, though these can all be refined at any time. Which leads us to step five, the data validation and updates. Habitat data and multipliers can be updated by ecologists within the platform or via our mobile application, which syncs with BNGAI. This is the process we use during ground surveys, but can also be desk-based. All changes are retained for audit purposes and visible during reporting. So on this project, working alongside AtkinsRéalis and the Eelscapes team, we co-created a combined approach using satellite imagery, AI-based habitat classification, and targeted ground survey. This custom methodology was pre-approved by DEFRA, giving it the regulatory credibility needed for biodiversity offsetting. The approach also combined land and river assessment tools together to provide a truly holistic overview for the project within the BNGAI platform. This partnership allowed us to assess both the terrestrial and the aquatic habitats comprehensively, ensuring that no critical ecological connections were missed. And the result was a robust, standardized approach that can be scaled and replicated across other similar projects, exactly what's needed to make biodiversity offsetting work at the landscape scale. So our Eelscapes methodology was tailored around four key strategic principles. The one was a targeted approach for high-value areas. Ground survey assessment was prioritized for the most ecologically valuable areas, while the BNGAI platform processed lower priority areas. This ensured that the highest accuracy happened where it mattered, while maintaining efficiency across the broader landscape. We also focused on data gaps. We concentrated on areas lacking existing habitat data, particularly where no prior survey data was available for model comparison. This targeted approach maximized the value of those field efforts. We also had a collaborative site collection. We worked closely with the Eelscapes team to collectively develop and refine the final site list, ensuring that the methodology aligned with their conservation priorities and local knowledge. And finally, we had dual-purpose surveys. The ground surveys were designed to serve two functions, validating the model predictions and accounting for locations where future habitat interventions were most likely to occur. So what did this strategic approach mean in practice? Well, we identified over 50 sites across the project area, which we split into batches and prioritized for processing on the BNGAI platform. Our strategic significance assessment used multiple data sources to make informed decisions about where to focus the validation efforts. Priority was given to high distinctiveness habitats, particularly SSIs in areas without field survey data, although we did exclude certain priority habitats like floodplain wetland mosaic and CGFM due to the sheer extent across the project area, which allowed us to focus our ground survey efforts where they would have the most impact. And from this prioritization, we selected 26 sites from batches 1 and 2 for ground surveys to validate the model. This ensured we were testing our methodology on those ecologically significant and data poor areas first. So what did we achieve? Well, 1,700 hectares were surveyed to a high precision in just 5 months. This included all fieldwork, data analysis, reporting, and consulting phases. To put this in perspective, traditional ecological surveys at this scale and precision would typically take 12 to 18 months. This demonstrates how technology can accelerate delivery without compromising precision. Delivering comprehensive ecological assessment, full reporting, and expert consultation within a fraction of the traditional timeframe. So beyond the speed of delivery, this approach delivered multiple strategic advantages. We had comprehensive coverage, we had highly accurate habitat classifications across the entire 1,700 hectares, and this included those hard-to-reach areas that traditional surveys often miss or inadequately access, particularly if we're talking about wetlands. A collaborative platform. All partners had a shared interactive space to interrogate results, validate findings, and develop strategic plans together. Cost efficiency. Significantly reduced the survey costs while maintaining regulatory compliance and scientific rigor. So this methodology is now tested and ready to scale across similar large-scale biodiversity offsetting projects to deliver better outcomes faster and more effectively than traditional approaches might otherwise. So this project highlights how powerful it is when technology and ecological expertise work together, which is exactly what our partner program is designed to facilitate for ecologists interested in being part of similar projects. So if you'd like to explore how this approach could work for you or your practice, simply scan the QR code and register for more information. There's no strings attached. Thank you.
Thanks, Lauren and Elle. I will just sum up some of the key points now in this slide. First one is that this was a really effective and efficient way to survey an extensive area, blending both AI and remote sensing with strategically located field surveys and leveraging the best of both approaches. And this is an approach that could be applied to other landscape scale schemes. Collaboration was key to monitor progress and share learning, and the interactive BNG AI platform provided a focal point for that collaboration. And finally, ensuring regulatory buy-in was also key, which I'm sure you will agree is really important when you're deviating from traditional approaches. I will just hand over now to Ashley, who's going to talk about the next stages of the project.
Thanks, Lizzie. So I'm just going to recap really briefly. Eelscapes is a partnership between WWT, Gloucestershire Wildlife Trust and the Environment Agency, working with 22 land managers. And we're aiming to restore nature-rich wetlands along the River Severn from Tewkesbury to Gloucester. The main issues that we're seeking to remedy are due to historic alterations of the rivers and their floodplains. Extensive drainage, physical barriers have severed the River Severn and its tributaries from their natural floodplains, and they've led to a loss of wetland habitats and declines in the threatened species that depend on them, including our focal species, critically endangered European eel. So during the development phase, we've carried out extensive baselining, including the topic of the webinar today. And this has informed our proposals to create, restore and enhance floodplain wetland mosaic. This is nicely illustrated in the CGI visualization produced by the Ruby Cube for the project, and it's showing improved connectivity between the main River Severn and the floodplain and other water courses, and temporary and permanent open water features, swamp, fen, wet grassland and wet woodland habitats establishing. Eelscapes is intended as a holistic project and we've been working with local farmers with the aim of supporting their farms to become more viable and resilient against a changing climate. And so you can see there are some cattle actually included in this visualization too. So we are still looking at a farmed landscape and kind of balancing that with the habitat and also access. So would you mind moving on to the next slide? Okay, so again, Eelscapes is intended as a holistic project, and so this means that we are looking to provide opportunities for local communities to gain the multiple benefits of experiencing high quality green and blue spaces. And this visualization illustrates new and enhanced wetland features and a whole range of improved and accessible access infrastructure. And we're also looking to deliver community engagement activities with educational, health and wellbeing benefits. We submitted our proposals at the start of this month, and we've entered the next phase, which involves assurance and negotiation with DEFRA to secure long-term support for delivery of works, ongoing maintenance and engagement programmes. And all being well, if we're successful, we hope to progress to implementation in 2026. So watch this space. Thank you.
Thanks, Ashley. That brings the presentation to a close. We can move on to any questions if anyone's.
Yeah, please, if anyone has any questions, please feel free to put it in the Q&A box. So far, I don't think we have any at this point, but we are waiting. Oh, we have one. This is the same badge event where the other operator is given the opportunity to advertise their approach. I guess I would want to ask to clarify approach to this project specifically, or approach to what exactly? If you'd like to answer or type in another question, that would help us. In the meantime, we have another one. Hi there, just wondering what you think the applicability of this would be at smaller scales. Who would like to take that one?
I can have a stab if you'd like, Anastasia.
Sure.
So yeah, just to say that I think this does, I mean, in terms of the way that BNG AI approaches it, certainly we do apply this at smaller scales all the time. So this was at the large landscape level, but even on a site that is maybe just sort of bigger than something you might want to do in a morning, this kind of approach obviously is very scalable. So we would pre-map habitats, which are then obviously validated by the ecologist on site, and a lot of those efficiencies and data savings, in terms of time savings, are actually like applicable on the small scale as well, because you're not doing a lot of data collation, and you can do your strategic thinking ahead of when you get to the project as well. So we call it optioneering. So even on a small scale, you can have a pre-map which helps you kind of validate the areas you may want to spend the most time on. It may help you understand if you need a specific NVC expert for that particular site. So if you're highlighting particularly sensitive wetlands, you might want to send your wetland expert. And so yes, absolutely, I do think it could apply both on the smaller scale as well as on the larger scale.
Thank you, Lauren. We have another question here.
Sorry, Anastasia, do you mind if I just jump in on that one as well?
Oh, sorry.
Yeah, for the River Studio tool, again, similar to Lauren's point that it is very scalable because of the types of data that we're using. Obviously, at a point, your site will become so small that you may as well just go out and do the survey. But when you do have a slightly more complex site or anything that is slightly bigger, then it is really helpful to give you a a starting point of the types of habitats that might already be there to help you stratify your survey. As for the river assessments, the Biodiversity Net Gain metric tells us that we need to sample 20% of that river area, and we need to cover the best bits of the river and the worst bits of the river. So this tool can really help you understand where you think those areas might be, so you can contact the right landowners and be a bit more strategic in your surveying strategy.
Thank you, Elle. Anything else to add? There's another question. Are there any plans to scale up the project to other wetland and tributary areas that may be more degraded, such as River Thames area?
I'm happy to. Oh, yeah. So
you go, Elle.
I was just going to say, so in terms of the project itself, so Eelscapes is funded from this pot of DEFRA landscape recovery money, and there are other landscape recovery projects within the Thames area, as you've suggested, that all have these similar requirements to go and baseline their sites and think about how we can improve these degraded habitats. So that is definitely something that is happening, but not necessarily directly related to the Eelscapes project.
Thanks, Elle. So we have another one here. Thank you for a great presentation. You mentioned that stakeholders can input indicators like strategic significance or encroachment into the data platform. What other variables may they be able to input and additional info to inform the tool? And I think that might be about the BNG AI tool. So Lauren, would you like to take that one?
Quite happy. So basically anything about the habitat, so anything that you would normally have in your BNG survey is editable within the BNG AI tool. So the first initial base map is essentially seen as like a preliminary map. So you can change the habitat name, the habitat type, you can change the boundaries, you can change any of the multipliers, any of the multipliers you can normally change. So you can change your condition, your strategic significance, and your encroachment values as well. So and all of that can then be changed like on a site-by-site basis and on a habitat-by-habitat basis as well within the platform. So if you could do it in a traditional survey, you can edit that data within the platform, and that includes boundaries.
And Lauren, I can see you started typing an answer to the next question as well. Would you like to take that one live in the meantime? Oh, sorry, we lost your sound for a second.
Is that the one about spatial resolution?
Yes, yes.
Okay, so our spatial resolution is we generally map at BNG AI to 5 by 5 meters. So it's the same as the de minimis that you would expect there. And we think we can get much more fine-tuned, but generally speaking, for a BNG project, we stick to a 5 by 5 habitat level. Some of our habitats are smaller, particularly in urban environments. So things like, boxes of introduced shrub if they're small, or we may have some features that do fall below that threshold, which we do pick up, and they generally tend to be in urban environments. But in most areas, we're looking at a 5 by 5 resolution, and that obviously excludes trees, which tend to be sometimes smaller than that.
Great,
and then how frequently can this be repeated to monitor habitat change? So we do have what we call our enterprise clients, which are clients who use our platform for their entire estate, and they tend to use us depending on what their regulatory requirements are. We can do an annual update. We find most of our clients need something in the region of every 2 years, depending on what they're doing. So it really depends on what your use case would be, but we think that we can do it at least once every year, and that's going to give you sort of at least a meaningful result that you can see your year on year during the growing season changes.
Thanks, Lauren. And sorry, we have a slight clarification above that I scrolled past. Sorry about that. So about the access to the tools and what's available to SAI members. So I guess I can take the side from AiDASH perspective. Like with BNG AI, as Lauren mentioned, we do have a partner program that is absolutely free to join for ecologists and SAI members specifically, that can let you explore the tool and also take on any additional projects if you would like to do that, as well as you get access to a lot of resources that are, well, created by our ecologists and for other ecologists. Of course, BNGI is not the only tool in the market. And of course, AtkinsRéalis's River Studio is another great tool that has its own platform. So if Lizzie or Elle, you'd like to talk about that, and I think maybe Sarah might have any other information on what other tools are available to SAE members as well.
Thanks, Anastasia. Yeah, just to say, obviously, yeah, these are two tools that we've developed and we put to use on this particular project, and yeah, we're just showcasing this approach to you today as an example of what AI and remote sensing might be able to do for a large scale scheme and possibly for smaller scale schemes as well. So yeah.
Yeah,
More to add.
on the River Studio front, as it is all based off open source data sets, and the tool was developed with the sorts of clients in mind that we're thinking about working with trusts and catchment partnerships and farmer clusters. It is designed to be quick and straightforward to run, and while it is, like you say, behind a paywall, it is not necessarily a very highly expensive tool to run.
Thanks, Elle. Okay, let me go through. I think, Lauren, you have marked another question that you would answer it live. I'm not sure. I don't think we've covered this one yet. What level of existing data is required for preliminary mapping?
So in the case of BNGAI, and I'll obviously let Eleanor talk about the River Studio side, but in the case of BNGAI, all we need is your site boundary, and that'll give us a preliminary map that you can then work off. If you did have additional data, then you can input that in on top of the preliminary map to refine it inside the platform. So from outside, all that we need is the AOI. We will reference all the other data layers in the background, and we do look at things like soil, priority habitats, we look at imagery, basically any of the open source data, plus some of our bespoke model data, some of our own bespoke data we pay for as well, things like the ancient tree inventory, all of that is brought into the platform. So you bring the AOI and we bring the preliminary habitat map, as it were.
That's exactly the same for River Studio. We just need your area of interest, and then the tool does the rest. But we can build in any bespoke data sets that you do have access to as well.
Great, thank you both. Okay, we have another one. So this one is from Nathan. What boots on the ground remote sensing is or will be used to supplement this data? That is eDNA, bioaquatics, camera traps. Is that a thing for yourselves, or do we have another alternative there?
I can take that one, Anastasia. Obviously, this was focused on habitats, which underpins the statutory biodiversity metric. So that was our focus. And Ashley, you might want to come in here as well. But as the project progresses and you identify your areas that you want to take forward to implement your interventions, then some more detailed surveys will probably be undertaken on those specific areas once things have refined down a bit more. And Ashley, I know you've also undertaken quite a range of different surveys within the project area as well.
Yeah, that's right. For landscape recovery specifically, we have a whole kind of bespoke range of indicators that we selected. So we undertook surveys for eel presence using eDNA in the water bodies. We've looked at the distribution and abundance of true fox sedge, which is another one of our focal species, modified Webb's count, which It's quite interesting because we're looking at areas which we intend to wet up, but of course they're not wetland at the moment. So that was a kind of modified survey. And also looked at invasive species, looked at hydrology, so all sorts of different things, but very much bespoke to the project.
Great, thank you. We have another question here that is very deep. Do you have, this one is from Finn, do you see environmental policies changing to accommodate AI for future ecological management? And do you see the overall issue of climate change being more accessible to the public with AI?
I can take a stab at that. I think I do think that we are going to see policy changing to sort of incorporate the use of AI, at least where it's appropriate to do so. So as we say, we always believe in a combined approach of AI and boots on the ground, particularly for certain applications, but there will be some applications. And if we think about a problem like small sites, which, we're doing a lot of consulting on at the moment, are there ways that we can use AI to maybe streamline some of the smaller sites or some of the areas where we expect to kind of have less impacts, and using that kind of scoping mentality that we have in EIAs, where we use like a scoping approach for sites where we kind of know the impacts and where we understand what the impacts might be. That's definitely a place where we can see lots of AI being applied in the process. And then in terms of making it more accessible for climate change, I think that's a complicated one. I think as all of these models become easier accessible and we develop tools, things like chatbots and Claude, etc., which you can actually do some like small scale modeling yourself. I mean, we have hackathons all the time in our company, and it's always amazing what people can do with these tools. So I do think it will become more accessible. I think it becomes a question of, as the tools become more sophisticated and we're able to develop more and more metrics, we'll develop that trust, which will then see the policy shifting and seeing those regulators getting behind it when the data's there to support the accuracy.
Thanks, Lauren. Anyone wants to add anything?
So I just add one more thing, which is exactly why projects like this are actually important, because it kind of starts to bring to the table the regulators, the people using the data, and companies like ourselves to explore what is the accuracy and can it be applied for regulatory purposes like this project.
Yeah, that's a good point. Thanks, Lauren. Now we have another more technical question. Are condition maps provided in raster or vector format?
For the River Studio, they're provided in vector shapefile format as a polyline.
We don't have specific condition maps, but shapefiles of the entire BNG sort of calculation and site are available. They're an additional service, but when they are available, they're available in shapefile format as well.
Thank you both. And we have another one here. Could AI and remote sensing be used to assess private garden habitat quality, providing a monitoring solution for private gardens in relation to BNG? And at the moment, they can't count towards BNG net gain.
Yeah, I'm happy to take that one as well. So my understanding is most of the reason why we are not counting biodiversity net gain in private gardens is more to do with enforcement. So your own private land ownership rights in a garden per se. You may want to change your hedge, or maybe your daughter's allergic to the lawn and you need to put a non-lawn in. And so that's one of the reasons why we can't secure BNG within private gardens. But yes, we absolutely see that AI and remote sensing can assess things like private gardens. We have experimented with it. We're quite confident we can already, and we do to a certain extent for BNG, already tell the difference between vegetated and unvegetated gardens. We pick up things like trees once they reach a certain site within gardens. And so when we are doing baseline, we do think that we can baseline private gardens, and we do it all the time. But the law obviously is there because of the land laws around ownership and how do you secure BNG within a garden, essentially.
Thanks, Lauren. Yeah, we have another one. Is there a way the public can get involved in surveying or data input, like open source? Who would like to take that?
So from the river side of things, there is a citizen science version of morph surveys, and that is a data set that we pull into the River Studio model, where I believe you go on a training course, but you don't become accredited in the same way. So there is an option to potentially get involved in that way so that the public can feed into the data that helps build the model. But in order to validate that model or to have specific or particularly for biodiversity net gain requirements, you need to have an accredited professional surveyor.
Okay, thank you. Right, I think we're pretty much out of the questions now. If you do have any more questions come up after the fact, please feel free to get in touch with us. For AiDASH side, you can get in touch at hello@bng.ai, but Sarah and Saeem organizers will be in touch with the recording, and so you can forward your questions that way as well. Sorry, if you'd like to add. Sorry, I was stepping on your toes there.
That's absolutely fine, Anastasia. Right, well, thank you ever so much for you joining us today and, giving your perspective on a well worth collaborative project that you've all been working on. And I think it just shows really how much further AI's come and how quickly. So, if anybody listening today is actually, really interested in AI, wants to find out a bit more, Saeem are running a conference on the 15th of July. So feel free to have a look at that and maybe join us. So really, all we'd like to do now really is just thank again Ashley from WWT, Lizzie and Eleanor from AtkinsRéalis, and Lauren and Anastasia from AiDASH from joining us today and sharing their project. And if you have any other questions or anything, feel free to send them to Saeem and we'll pass them on. And have a lovely afternoon, everybody. Thank you very much.
Thanks, everyone.
Take care.
Thanks, everyone.